Welcome to Geometric Galaxy. Hi students, in this video we will see chapter 2 polynomials exercise 2.3 question number 3 and question number 4. Here is question number 3. Find the value of k if x minus 1 is a factor of p of x in each of the following cases. Here we have 4 subdivisions. Let us see one by one. As per the question, x minus 1 is a sure factor of all the following polynomials. So, according to factor theorem, p of 1 is equal to 0. So, using that concept, we are going to find the unknown value k in all the polynomials. So, in the first one, if x minus 1 is a factor of p of x is equal to x square plus x plus k, then p of 1 is equal to 0 by factor theorem. So we are going to find what is p of 1 for subdivision 1. So p of 1 is equal to 1 square plus 1 plus k is equal to 0. 1 square is 1, then plus 1 plus k, that is 2 plus k is equal to 0, which means k is equal to minus 2. Therefore, the value of k is minus 2 if x minus 1 is the factor of the polynomial p of x is equal to x square plus x plus k. Here is subdivision 2. Here also same, x minus 1 is a factor of p of x is equal to 2x square plus kx plus root 2. Then by factor theorem, p of 1 is equal to 0. Now we will substitute 1 in the place of x. So we get p of 1 is equal to 2 into 1 square plus k into 1 plus root 2, which after simplification we get 2 plus k plus root 2 is equal to 0. Therefore k is equal to minus 2 minus root 2. We can also write k value as minus of 2 plus root 2. Therefore the value of k is equal to minus of 2 plus root 2 if x minus 1 is the factor of the polynomial p of x is equal to 2x square plus kx plus root 2. Third subdivision. Here also x minus 1 is a confirmed factor of p of x is equal to kx square minus root 2x plus 1. So then by factor theorem, p of 1 is equal to 0. Now we will find the p of 1 value and equate it to 0. So p of 1 is equal to k into 1 square minus root 2 into 1 plus 1 is equal to 0. That is, after simplification we get it as k minus root 2 plus 1 is equal to 0. That is, k is equal to root 2 minus 1. Therefore the value of k is equal to root 2 minus 1 if x minus 1 is the factor of the polynomial p of x is equal to kx square minus root 2x plus 1. Now let us find the k value for our fourth subdivision p of x is equal to 4x square minus 3x plus k. As per the question, x minus 1 is the factor of p of x is equal to kx square minus 3x plus k. Then by factor theorem, p of 1 is equal to 0. So let us now find what is p of 1 and equate it to 0. So p of 1 is equal to k into 1 square minus 3 into 1 plus k is equal to 0. Therefore 2k minus 3 is equal to 0. So the k takes the value 3 by 2. Therefore the value of k is 3 by 2 if x minus 1 is the factor of the polynomial p of x is equal to 4x square minus 3x plus k. The fourth question of this exercise is factorization. Here we have 4 subdivisions. We will do factorization of these 4 quadratic polynomials one by one. In the first subdivision, we have 12x square minus 7x plus 1. A quadratic polynomial can be factorized either by splitting the middle term or by using appropriate identity. Now we need to find two numbers whose sum is minus 7 and the product is equal to 12. That is, we are multiplying the coefficient of x squared with the constant term. Therefore, I have written 12 into 1 which is equal to 12. The coefficient of the middle term should be the sum of those two numbers. Now we need to think of all those factors of 12 and analyze where we get the sum of those numbers as minus 7. If we see in one table, we get 1 into 12 as 12. So I have taken the first factors as 1 and 12. But 1 into 12 is 12. 1 plus 12 is 13. So we are not getting the middle term as minus 7. So we need to check with other number. You see, 2 into 6 is equal to 12. But 2 plus 6 is equal to 8. Here also we are not getting minus 7. Now I will check with another pair of numbers 3 and 4. So 3 4s are 12, but 3 plus 4 is equal to 7. So we need minus 7 as the sum and the product as plus 12. So we can take minus 3 and minus 4. If I add minus 3 and minus 4, I will get minus 7. And if I make the product of minus 3 and minus 4, we get plus 12. Now let us split the middle term minus 7x as minus 3x and minus 4x. So the polynomial becomes 12x square minus 3x minus 4x plus 1. Now we have 4 terms, but there is no factor other than 1 common for all the 4. So we will take the common factor out in the first 2 terms. Next we will take the common factor out in the third and fourth term. So in 12x square minus 3x, we have 3x as common. So we can write it as 3x into 4x minus 1. In the third and fourth term minus 4x plus 1, nothing is common, but I need the same factor 4x minus 1 here. So I take minus 1 out from minus 4x plus 1. So if I take out minus 1, it becomes 4x minus 1. Now in the third step, if you see, we have a common term 4x minus 1 in both the terms. So I will take 4x minus 1 out. So I am left with 3x minus 1. So it becomes the product of two factors 4x minus 1 and 3x minus 1. Second subdivision is 2x square plus 7x plus 3. We need to find two numbers whose sum is 7 and the product is 2 into 3. Again I repeat, the sum is the coefficient of middle term and the product is the product of the coefficient of x square 2 and the constant term 3 as 6. We need to get the product 6. So 1 into 6 is 6. If I add 1 and 6, I am getting 7. Therefore the sum is 7 and the product is 6. So I can use the factors 1 and 6. Both are positive. So now take 2x square plus 7x plus 3 and split the middle term 7x as 1x plus 6x. So we get 2x square plus 1x plus 6x plus 3. In the first 2 terms, we can take x as common. So I get x into 2x plus 1. In the second 2 terms, I can take 3 as common. So plus 3 into 2x plus 1. Now we can see the 4 terms becomes 2 terms. In the 2 terms, I have 2x plus 1 as common. So I will take it out. Then I will be left out with x plus 3. So the final answer is 2x plus 1 into x plus 3 or the factors. Our third subdivision is 6x square plus 5x minus 6. We need to find two numbers whose sum is 5, the coefficient of middle term and the product as the coefficient of x square and the constant term. So we get 6 into minus 6 is equal to minus 36. Now we will check all the factors of 36 by trial and error method. First I will check with 1 into 36 is 36, but 1 plus 36 is equal to 37. So we can't use these numbers to split the middle term. So I will check with the 2 and 18. 2 18s are 36, but 2 plus 18 is equal to 20. We are not getting middle term as 5. So we will check with another set of numbers. 3 12s are 36, but 3 plus 12 is 15. So we will check with another pair of factors 4 and 9. 4 9s are 36, but 4 plus 9 is equal to 13. But the coefficient of our middle term is only 5. So I can check with the minus 4 and 9. If I multiply minus 4 and 9, I will get minus 36. and if I add, I'll get plus 5. So this is the suitable factor for this problem, minus 4 and 9. Now we will split the middle term 5x as minus 4x plus 9x. So we can write 6x square plus 5x minus 6 as 6x square minus 4x plus 9x minus 6. So if I take the first two terms, I can take 2x as common out. So I will get 3x minus 2. In the next third and fourth term, if I take plus 3 as common, I will get 3x minus 2. Now I can take 3x minus 2 as common. So I am left out with 2x plus 3. Therefore, the factors of the given polynomial is 3x minus 2 into 2x plus 3. Here comes our fourth subdivision. P of x is equal to 3x square minus x minus 4. We need to find two numbers whose sum is minus 1 and the product is minus 12. We get minus 12 by multiplying the coefficient of x square 3 and the constant term minus 4. Here one important thing you have to note, the middle term, that is the coefficient of x is minus 1. If we come across the coefficient of the middle term as plus 1 or minus 1, then the two numbers what we have to choose will be consecutive numbers. For 12, the consecutive factors are 3 and 4. But we need minus 12. So one factor will be positive and the other factor will be negative. Then only we will get the product as minus 12. Now we should decide which factor should be negative and which factor should be positive. If we take minus 4 as negative and 3 as positive, we will get the sum of plus 3 and minus 4 as minus 1. Instead, if we take 3 as negative and 4 as positive, then we will get the sum as plus 1. So accordingly we have to choose which factor should be negative. Now we will split the middle term of 3x square minus x minus 4 as 3x square minus 4x plus 3x minus 4. Now let us take the first two terms and see what is common in that. So in 3x square minus 4x, the common factor is x. In the third and fourth term, 3x minus 4, the common factor is 1. So we can write this as x into 3x minus 4 plus 1 into 3x minus 4. Now we can see 3x minus 4 as common in both the terms. So we will take out 3x minus 4, leaving x plus 1 as another factor. So the factors are 3x minus 4 and x plus 1. This we will come to an end of this video. In the next video, we can see exercise 2.3 question number 5. If you find Geometrix Galaxy helpful, consider subscribing to my channel. And please don't hesitate to recommend this channel to your friends. Thanks for watching.